Okay, today we're going to be talking about the Pythagorean theorem, and this time we're going to be talking about finding A and B. So the essential question is asking us, how can you find the missing leg of a right triangle? In this case, the missing leg would be A or B. Last week we worked on finding C. This week we're going to be finding the missing leg of a right triangle. As I write and circle, make sure you are doing the same thing on your paper. So let's just review our vocabulary very quickly so that we, as we write, we make sure that we have the correct terminology. The Pythagorean theorem, we've been talking about that, is a squared plus b squared equals c squared. Let's draw ourselves a little picture of a right triangle. Don't forget, we always want a right angle in the corner. C is always across from the angle, and A or B are its legs. Let's talk about what it is to be a right triangle. It is a triangle that contains a right angle, or we could say 90-degree angle. Either one works. So when we say right angle, that means that little box right there. Let's talk about a hypotenuse. The hypotenuse is the longest side of a right triangle. So let's go ahead and write that in. It is the longest side of the right triangle, and we call that C. So make sure you have that C there in parentheses. Next, we're going to talk about the legs of the triangle. So the blank of the right triangle that form a 90-degree angle. So in this case, if it forms a 90-degree angle, they are the shortest sides of the right triangle, so shortest. So let's go ahead and write in the word shortest, and then we're going to write sides, the shortest sides. And I'll go ahead and zoom in on that so you can see it, the shortest sides of a right triangle. And we call these A and B. So we're going to go over just above, somewhere near 90 degrees, and we'll put A and B. And lastly, let's talk about a square root. So everybody go ahead and draw the square root sign. And the square root is the inverse of a squared number. The inverse of a squared number. So if we have the squared number 4 squared, which equals 16, to undo it, we would do the opposite by breaking it down, which would be 4. So again, the Pythagorean theorem is our a squared plus b squared equals c squared. Our right triangle always contains a right angle, and in this case, you'll see it here as I color in that little red box. Our hypotenuse is always the longest side, so C is always the hypotenuse. Remember, it's a Greek word having to do with the fact that this hypotenuse is always slanted. The shortest sides are our legs, that would be A and B are always our legs, and then inverse of squared number is a square root. So now that we've had just a quick little review of our vocabulary, let's go ahead and move on to our example. So the first thing we're going to do is we're going to solve this example, and then you'll be doing some with the teacher and then on your own. So let's go ahead and start identifying some things. I see the right angle here as I go over it, and I know that C is always across from that right angle. So I know for sure this has to be C, which is a little bit different than last week because last week we were finding C. And then I have my A and B legs. So I have my hypotenuse of C. I'm going to go ahead and say this is A and this is B. So once we do that, let's go ahead and write out all of the important information that we typically write out when solving for a Pythagorean theorem. Now, remember you guys, if you see a right triangle on any test or assessment, you know for sure you're already going to use the Pythagorean theorem. In fact, if you see diagonals, you know you're going to use a Pythagorean theorem. Okay, so let's fill this in. We have 13 for A. I'm going to ignore the units yards for now. I'll put it at the end. I have X for B, and for C, I have 15. So let's go ahead and write out our Pythagorean theorem. A squared plus B squared equals C squared. Let's fill in our legs. So the first thing I'm going to do is I'm going to fill in these two pieces of information that do not change. Then I'm going to look for my first leg, which is leg A, which is 13. So I'm going to go ahead and write 13 squared. And I'm going to look for my second leg for B, which is X. So X squared. Or you could put B squared. It really doesn't matter. And then my last piece of information is C, which is my hypotenuse, which I see up here at the top. And my C is 15 squared. So now let's punch this into your calculator. I'm going to go ahead and put in my calculator 13 times 13. So let's write this out. 13 times 13, 15 times 15, and X times X. And don't forget to put your plus sign. I see some people forgetting to put these two symbols, which are really, really important. So let's go ahead and open up our calculators and type in 13. Oops, put that in wrong. 13 times 13, which equals 169. So 169. Again, I want to put my plus sign and my equal sign here. Okay. X times X, I can't put that into the calculator, but I know that already gives us X squared. Okay, let's put in the second piece now. Let's put in 15 times 15. So go ahead and enter that into your calculator, and you should get, that's correct, 225. So let's go ahead and write that down. So good job, you guys. Some of you are a lot faster than I am. Now, lately, for the last week and a half, we've been just adding these two items up, but this time we can't add because I don't know what X squared is. I have no idea. So I'm going to do what I did our last unit. I'm going to move over my constant. So I'm going to subtract my constant. So we're just doing the opposite now. Instead of adding, we're just going to subtract. So let's subtract by both sides. I know this right here on my left, 169 minus 169 gives me 0. So I'm going to cross it out. Let's put that into our calculator. 225 minus 169. Okay, that gives me 56. So on my right-hand side, I have 56. And on my left-hand side, I still have X squared. So I'm going to bring that down. Now we do what we did last week. We're going to take the square root. We're going to undo this so that we're going to do the inverse so that we can just get X by itself. So let me move this up just a little bit. And we're going to draw our two trees. And on this side, I know it's X times X. Let's put in the square root of 56. So I'm going to put this into my calculator, square root of 56. Don't forget your end parentheses. Okay, so here's what I get. I get 7.4833. I could keep going. So I'm going to write that on my branches. It's obviously what we call an imperfect square root. So I have X equals. Now let's round this. I'm going to go ahead and put 7.483, but we're going to round it to the tenths place. So let's look at the tenths place. And let's circle the hundredths place. Okay, I see this right here is bigger than 5 or bigger. So this is going up. Okay, so my final answer should be X equals what, you guys? Correct. X equals 7.5. And then don't forget your units, yards. That is very important. 7.5 yards. And I want you to put this note just so that you remember this is what we call an imperfect square root. Okay, imperfect square root.